If you ever see a question talk about a percent increase or decrease, there's a good chance that question is setting you up for a trap. For example, if I told you that my business made twice as much in January as I did in all of last year, that might seem pretty impressive. But if you then found out that last year I was unemployed and I only made $20, then all of a sudden a business that makes $40 in January doesn't seem that impressive. On the flip side, if I said that our business made $50,000 last month, you might think that sounds like a pretty good business. But if you then found out our business was the entire McDonald's Corporation, which has about 34,000 different locations, that works out to be about $1.50 profit per McDonald's restaurant. Now that $50,000 doesn't seem like a big deal. So the common fallacy these questions like to test you on is the assumption that a big number is also a big percent, or a big percent is also a big number. But as we've seen, that isn't necessarily the case. Let's see how this is going to work in a passage from a recent exam. The question starts off describing how the percentage of retirees moving to Arizona is going to decrease by 10%. And at the same time, the number of couples moving out of Florida, that's going to double. And as a result, they're expecting a large drop in the population. Let's dissect this argument so we can figure out where the flaw might be. We have the state of Arizona, which I'm pretty sure is shaped like a box. And in Arizona, they have every year people moving into the state, and every year they have people moving out of the state. While normally they might have R amount of retirees moving into the state and C amount of couples moving out of the state, they're predicting a shift. They are predicting that the retirees will drop by 10%. So now we only have 0.9 retirees moving in. And at the same time, the number of couples, that's going to double. So now we have 2C couples moving out. That might seem like a problem, but remember, we don't know the actual values for R and for C. So we really don't know if a 10% drop or a double in the number of couples, we don't know if those changes are a big deal. We also want to pay special attention to what is actually decreasing. The way the question is phrased, it makes it sound like less people are moving to Arizona. But it doesn't actually say the percentage of people is less. It says the percentage of new retirees moving, that's going down. So one way to weaken this argument would be to say that the total number of people who are expected to retire, that is going to dramatically increase. For example, if last year we had 200 people in the entire country retire, and 50% of those moved to Florida, and the other 50% moved to Arizona, that means that last year 100 people moved into Arizona. But if next year the total number of retirees goes up, so now we have 400 retirees, and the percentage goes down, whereas last year 50% moved to Arizona, so this year only 40% are going to move to Arizona. That would mean that we have a total of 160 retirees moving to Arizona. So it would be possible for the percentage to drop, but the total number to actually go up. If you wanted to strengthen the argument, you could say something like the number of retirees moving into the state, that's equal to the number of young couples moving out. And that would support the idea there's going to be a population drop, because if the numbers are the same and one number decreases by 10% and the number leaving doubles, then you're certainly going to have a net loss. Now, could you call that drop in population? Could you call that a large drop in population? Probably not. For that, you'd have to have some actual numbers. Here's a question where the writers hope you assume the numbers they talk about are all equal, but they might not be. In this situation, we have the number of students enrolled in college. That number is going up. So the author assumes the number of workers entering the market with a college degree, that number is also supposed to be higher. On the surface, this argument seems to make sense. But we have to pay attention to the subtle changes in the language. Just because you are enrolled in college, does that mean that you will get a degree? Or does it even mean that you will one day become a worker? It could be that if you are enrolled in college, you will likely one day get a degree and you will likely become a worker, but we don't know for sure, and that's where the argument is flawed. There are several ways you could weaken this argument by destroying the assumption that the numbers they're talking about are equal. If the number of students dropping out after the second year, if that number is going up, then just because you're enrolled doesn't mean you will necessarily get a degree. Or if a lot of the students who are going to school are actually retired and they just want to go to college to learn, that means that one day they may never be workers with college degrees. They will simply be non-workers with college degrees. There's also one more possibility that's a bit more creative, and that is that the number of years it takes to get a college degree is increasing from 2 years to 4 years. And once again, to see how this could weaken the argument, we have to pay special attention to the wording in the original passage. The passage talks about the number of students enrolled, which is different than the number of students enrolling. For example, if you had 50 people entering a college every single year, that would mean you would have 50 freshmen and you would have 50 second-year students. And if it were a 2-year college, you would also have 50 students leaving every year. So at any point, you have 50 going in, 50 going out, with a total of 100 students enrolled. However, if you took that same school and converted it to a 4-year college, you could still have 50 students going in, and then you would have 50 students in every class, and eventually you would also have 50 students leaving and graduating each year. So by simply changing the number of years it takes to get a degree, you can change the number of total students enrolled from 100 to 200 without actually changing the number of incoming and outgoing students every year.